I am Anil Kumar, and now let us understand what is limit of a function with the help of this video. Now in this particular case, I'll take two examples and then we'll explore and understand what really limit of the function is, when will it exist, when will it not exist, right? So that is a very critical question which we will be answering in this particular chapter. So let me consider two functions. First function I will take as a rational function. Let it be x square minus 4 divided by, let us say, x plus 2. And I would like to take a very similar function here, so which I'll take an absolute function, which is a very similar function. Let me keep the denominators maybe same, okay. But we'll keep the function as absolute in the numerator. It could have been taken in the denominator also. It doesn't really matter. So I have taken a very similar kind of a function, and the idea here is to understand the limit of the function at x equals to minus 2, right? So here you observe that there is of course a restriction that x is not equals to minus 2 in both these functions, correct? Now idea of limit is that we have to get closer to the point of interest. We may not be there. So even if the point is not there in the domain of the function, we can still find limit of the function at that point since we are approaching that point. So I hope that concept is absolutely clear. And one of my ideas of taking these two functions is to emphasize that the limit really means we are approaching, right? So we are approaching. So I have a definition here which we'll further explore, but says limit of a function y equals to f of x as x approaches a value a, right? So as x approaches a value a is very important to understand. And we are going to write this as this kind of a thing, correct? So let us find limit of the function of f of x in this case as x approaches minus 2, okay, minus 2. The function, I'll write f of x here. And same case here, we will also explore what happens to the limit of this function as x approaches minus 2 for g of x. So we'll work for both these examples in kind of parallel and understand the situation. You can actually pause the video, try to do it on your own as a practice, and then look into my suggestion. So, okay, let us further factor this particular statement since I wrote this here. This is not regarding, okay, let me write like this. So we will explore this and we'll say limit as x approaches minus 2, and instead of f of x, let me write the function itself in factored form. Okay, that works. So it is x plus 2 times x minus 2 divided by x plus 2, right? I'll not be writing the restriction again and again. It is well understood, right? Now we can simplify this and we can write this as limit of function x approaches minus 2 and x plus 2 cancel. So we are left with x minus 2, right? So that is what we are going to explore. Now further getting into the details, let me kind of sketch this on the side. So we'll just sketch this. So it is a straight line, as you can see, where the x minus 2 means positive slope, y-intercept as minus 2, right? And x-intercept will also be at 2, right? So we can draw a line, but one important thing here is that at minus 2, it is not defined. So at minus 2, so let me just take some points here. So this is minus 2. If it was defined, then the value could have been minus 2 as minus 4. So minus 2, and then this is minus 4 for me, okay. So here it is not defined. This is minus 4 for me, okay, and that is minus 2. Okay, this is 2, this is minus 2. So I'll sketch this line here. It is defined all throughout like this, but not at this point. That's the whole idea. I hope you can see it. So this straight line represents our function f of x, x square minus 4 divided by x plus 2. Correct? Now the idea is we need to find limit of the function as we are approaching minus 2. How do we do it? Now to find limit, the concept here is that we have to find the left side and right side limits. So let me write down left side and right side limit. So what do I mean by that, right side limit? Left side means approaching minus 2 from left means I'll write, the convention is to write like this, limit x approaches minus 2 and this minus on the top of the function f of x. So f of x is sufficient, I don't have to write the expression, right? So when I say what is the limit of function f of x when x is approaching from left side of minus 2. So if I am here, the value is somewhere there, correct? As I approach closer and closer, I am approaching a value of minus 4. So this value for me is minus 4. You can clearly see, right? So as I am approaching from here, I am approaching value minus 4, correct? So that is the value I am approaching. How about when I am approaching from the right side? So when I am approaching from the right side, I'll write like this, limit x approaches minus 2 plus. Plus means approaching from the right side for the function, same function. This is our function f of x, right? What is the value we are approaching? So if I am approaching from here, I am also approaching minus 4. So this limit is also minus 4. What we clearly see in this particular example here is that both side limits is same, right? So both side limits are minus 4. So what we observe here is the limit when x approaches minus 2 from left side for the function f of x is equals to limit when x approaches minus 2 from the right side, right, for the f of x. And both these limits are actually equals to minus 4, right, this value. Therefore, we say that the limit of the function at minus 2 is minus 4. It is defined and it is minus 4. And therefore, this implies that the limit when x approaches minus 2 for the function f of x is equals to minus 4. That is what this chapter is all about. So whenever you're working with functions, you have to test the limit from both the sides. If the limit is same, then it exists, and if it is not same, it does not exist, right? So in this case, it does exist, correct? You can clearly see approaching from either side, you're approaching a value minus 4. Now let's get back to the second example, which is absolute x plus 2 divided by x plus 2. Individually, if I have to sketch these two functions, then how will they look like? Absolute value of x plus 2 is kind of absolute x moved 2 units left. So just let me move it 2 units left and sketch this function. So this is my function, which is absolute x plus 2. Perfect. Now let me take another light color to sketch the line x plus 2. So x plus 2 also means that it is going through, this is your y-intercept, so that is the line x plus 2. Okay, so this is my other function, which I am saying is x plus 2. But g of x is what? G of x is quotient of these two, right? So you are dividing one by the other to get g of x, correct? So if I divide, let us say this is one particular value 2. If I divide 2 by 2, you get 1, right? So if I divide positive quantity by a positive quantity, I will get 1. But if I divide positive quantity by equal negative quantity, I get minus 1. So basically what we get here, so in the graph, basically this is minus 2, right? But when I divide, then I get what? Plus 2. But minus 2 is somewhere here for x. Okay, let me write here. Now when I divide the right side of minus 2, absolute x plus 2 divided by this, I get plus 1, right? Because both are positive. They are equal in value. So I can graph here like a hole here, because we are not considering minus 2. On the right side of minus 2, it is going to be always 1. On the other hand, if I'm dividing, let us say minus 3, if I put here minus 3, I will get minus 1 as my result, right? So minus 1 will be my result. So after this, here on this side, I will see that the graph is kind of like this. So this is g of x, which I have drawn here, correct? Where these values are 1 and minus 1. Perfect, right? Now if you observe here, can you write down what is the limit of g of x as x approaches minus 2, but from the negative side? I would like you to write this. Similarly, write down what is the value of limit of g of x, okay, when x approaches minus 2 from the positive side. So if I'm approaching from the negative side, that means I'm on this line and I'm approaching minus 1. So this value is minus 1. But when I'm approaching minus 2 from the right side, I'm traveling along this path, so I'm approaching the value plus 1. So here we are approaching plus 1. Clearly, what we observe here is that these two limits are not same, right? Minus 1 and plus 1 are not same. They're different values, and therefore we say that the limit of the function g of x as x approaches minus 2 does not exist. Reason is that the limit from left side, that is x approaching minus 2 from minus side, is not equal to limit x approaches minus 2 from the positive side. So that is the reason. So that is how we justify that the limit does not exist, right? Even if you clearly see from a graph, you need to justify, correct? So that is how you justify. So let's get back to our statement now. It says the limit of a function y equals to f of x as x approaches the value a, and it is written as limit of x approaching a for f of x is equal to L, exists if and only if the left side limit x approaching minus a and the right side limit x approaching plus a both are same. So I have written L for same. So this is a general statement. In our case, a is minus 2 and L happens to be minus 4 in the first case from both left and right side, and since it was same, limit exists for the given rational function, but it does not exist for the combination of absolute and the linear function as shown. I hope that example gives you a clear view of what we are trying to understand in this chapter. Also follow some of my links. They will help you to get a better grasp on the topic. Thank you and all the best.